His is probably relatively important, but not overly entertaining. But he's actually lost about 2 weeks because some grad students broke the server he was working on. So
it was more than that too, because it took 2.5 weeks to get the right credentials. So altogether, I'm out on 5 weeks.
Yeah.
That's like half a semester.
It'd be all right. Yeah, it'd be all right. At the end of the day, I'm a pretty fair grader. Like with this extra credit crap, I don't mind. I'm perfectly fine with everybody having 100% in quizzes. I don't give you quizzes to try to hurt your grade. But if you suck at quizzes, then you better show up to this extra crap.
Or if you don't show up in class.
Right, Pebbles? I turned this on. Why isn't this on? Oh.
That thing was acting up yesterday.
No, it's fine. It's just on the wrong. It's on the one of the other settings.
611 messages.
He doesn't read them.
Where's this?
In your
Right
email.
there. All unread messages.
Yeah, it's probably because the angel mail gets sent to your phone too.
Oh, this guy?
No, the angel mail gets sent to like 2 different places.
Yeah.
Oh, this.
Yeah.
Oh, yeah. I don't read it on Angel. I read it on my email.
So that's where all my angel messages are going.
No, I get them on my normal email. Okay, so I was checking. You said I have multiple homework 15s?
Oh yeah. If it's not like on the assignments, it's in the grade book as multiple homework routines.
Yeah, that's weird.
15 was the one due last Thursday.
I wonder if I've hit the maximum number of assignments.
Darn. Oh, man.
Did I give you assignment due today?
No.
Man, why?
Because you ran over
10 minutes late last time.
Oh, that's right. I did. I went over. I said, why didn't somebody tell me to shut up? And then you said it because you wanted to learn. You like learning.
Yeah. Well, if we don't get homework assignments, we're not going to tell you.
See, I almost didn't survive. I almost didn't make it here today. I bought a boat yesterday.
Oh, she let you buy one?
Okay, so here's... This is actually a pretty good story. And we'll get it recorded for, in case I need this for like police evidence or something. All right, so I was doing the inflatable thing, right? Okay, so it popped. My inflatable boat popped. I wasn't on it. So I figured if a thing can pop while sitting still in the garage, probably shouldn't have a couple of fat people on it in the middle of a lake.
What happened? Was it overinflated? Did
No.
It get poked?
It must have gotten poked. There were 2 puncture things. I fixed it. It was holding air after that, but it was kind of like you start losing faith because if you're gonna have to be schlepping this thing, schlepp. That's a Jewish. Is that Yiddish? Jewish. Schlepp. Okay, if you're gonna have to be schlepping this thing, I can say it because I was born Jewish. It's cool. My grandma has all sorts of made up words. Pishka. You heard of pishka before? So like in your car, you have the little container that you have change in for tolls. That's a pishka.
There's a name for that?
In Yiddish, there's names for everything.
Isn't that ashtray?
Yeah, so I come from my whole family is like extremely Orthodox. Like I have most of my relatives practice whatever their occupation is in like the full Jewish garb. I got cousins who do the curly stuff. Walk everywhere, don't use electricity on certain days of the week. I always think it's funny. Like, no, it's Judaism. They're not allowed to use Amish can't use electricity at all. Jews, there's the day of rest. So on the Sabbath, you can't use electricity. But see, it's not that they can't use electricity. They can't work to turn the light on. That's the difference. So what they do is they hire Gentiles to come turn the lights on for them. So there are people in Jewish communities whose job it is to go and flick light switches for the Jews.
I've heard that before.
It's totally true. Totally true. Most of
I could be getting paid to flip light switches for Jews.
And like most of my cousins are in arranged marriages. It's like a thing, so they get shipped over to Jerusalem to go to school and stuff, and but there's not very good health care over there. One of my cousins bit the bullet during childbirth because I don't know something that would have been pretty treatable here. But,
We lost track of the boat story.
did we?
Yeah, schlep.
Schlep. That's where we got to this. Words for the Pishka. That's it. Okay. So in any case, so the boat popped. So I decided, okay, so no more boat. So I set a budget for myself because I'm not going to spend a whole lot on this boat because I want to make sure, so I wanted to get a small boat. But I also had to be a boat that was going to hold me. So I decided even, with this popping problem, it wasn't going to be all that stable anyways, even though we were putting a wood floor into it. So I decided, okay, I'm going to go and find another boat. Well, in order to find a boat that was stable enough and ran all right for somebody my size, I really had to get into more of the drug dealer, drug user type of arena. You had to find a situation of desperation. So I found this guy who had kind of, maybe it's about a $4,000 boat that he was asking $1,500 for, that I offered $1,250 cash for, and he said good because he doesn't have a bank account and he can't go near banks.
That's not scary.
Okay, yeah, and every single time I talked to this guy, I went down to his place first. I brought a friend, and when I bought the boat, I made him bring it up to me. I wasn't going back there. This guy was high as a kite, and drunk, both. So in any case, he came up here yesterday driving the boat. He was just driving the boat on the interstate. So he was dragging it. So he pulls it up here. He's got 2 kids in the car with him and his cousin. Okay, and this guy his blood alcohol level had to be a minimum of like 1 point something, 1.2.
One.
I mean, it was, yeah. I mean, he was gone, and he was high, and he's driving kids around while pulling a boat. Yeah. So, anyways, I bought the boat from this guy, but I had backup there. I had other students that I was going to use for human shields in case I. Well, in fairness, I did tell the students that I was going to use them as human shields in the case things got. So that's reasonable, isn't it? I think. Yeah. So I got this boat from a guy who was definitely a drug user. I suspect probably a drug dealer, but I think he owed somebody some cash and needed some quick money.
Better check that boat, see if there's any hidden compartments.
My wife told me, make sure there's not a body. Because this guy kept referencing his, he kept referencing her as his fat wife. When he was saying that I would fit in the boat, he's like, oh yeah, it's 270 pounds, the queen bee sits right up there. Never met this lady. Wife thinks she might be under the floorboards in the boat. So I have to kind of inspect that. It's Adam and Eve, ADAM, ampersand, Eve, EVE, lowercase, all lowercase. It's a website him and I have been using.
Is it not like
Yeah, what's up?
Interesting
Million
name.
No, it's the password for the Wi-Fi password for Eden, the Eden network, which I would say is the network of choice, personally. All right, so 1 homework 15, but yeah, so I survived that. We're gonna actually take the boat out here around noon for like an hour or so and see if it sinks. It seems like it's in pretty good shape. Like the person who knows about boats I brought with me thinks it is worth maybe as much as $4,000, but way more than $1,250. Way more than $1,250. Plus, if the body in there has any sort of gold or silver fillings, you have.
Mine's post-ad. Pays for itself.
This guy did not seem like the type that would leave a whole lot behind.
Way to keep a happy thought.
So I'm pretty sure but at least I have a recording. I got nothing to do with drugs. Anything found in my boat came from this dude. I have a picture of this guy. You can see he's just completely lit up. I made him pose for a picture with the bill of sale in case.
Good move. Oh, yeah.
He couldn't even count the money.
Well, that might be his education.
It's a Honda.
Yeah, I got to see it firsthand this morning.
Was it in the intersection?
Huh?
What was it in the
Yeah.
intersection?
No, right in the intersection.
That
They
might be his
closed off the
education.
entire intersection.
So this guy couldn't even count. So he's trying to count the money, and then he was like breaking it into piles of hundreds, but it was windy, so it was like blowing away. So I said, "Dude, why don't you just have your cousin count it or something? I mean, it's all there. Trust me." And he's like, "Oh, it seems like you showed a doobie." Like, it's all there. Give me the fish finder and leave. All right, so you saw a car accident?
Yeah, it was awesome.
Yeah?
Yeah, Hondas can take a hit. Priuses?
Not so much?
No.
Was anybody hurt?
No, everybody was
All
fine.
right, so we can make fun of it now?
Yeah.
You always want to make sure. You don't want to make
Yeah.
fun of an accident where
Right.
somebody was severely injured. I mean, if they broke a finger, I'm okay with
Yeah.
making fun of that.
So maybe.
But if you get
Like airbags
you have a
deployed,
lost
but-
limb, oh yeah, I'm cool with like broken nose from airbag.
Yeah.
You can make fun of that. But if there's like 3 ambulances and they're like resuscitating somebody in the interstate, yeah, that's just bad.
The Honda still looked somewhat drivable. The Prius, the front end was gone.
Where was this?
Right at the intersection of 660 and Port.
Oh, out by my house.
Yeah, I went to leave early and then I'm like driving down the road, so bam! I'm like,
Huh.
cops have a great response time, by the way.
Well, that's only 2 blocks from the cop station.
I've seen worse. I've seen them take 10 to 20 minutes.
One time out at the football field, we had a guy break his arm into 2 pieces. It took the ambulance 45 minutes to get him.
Really?
And hot sauce right across the street.
Was the bone sticking out?
It was close.
Oh, I love that. I love when the bone pops through the skin.
Couple quarters later, another guy dislocates his elbow. So
Anybody? How far are we into the class already? So we're like,
15 minutes.
yeah, we're 12. The first 12 minutes of this class is just gold. we got Yiddish. We got drug dealers.
Broken bone.
In car
Yeah.
accident.
Probably the couple years ago in the NCAA tournament, the guy that did with the shin. I saw that. It was I was in Las Vegas airport, and I was watching it when it happened. Something's wrong with me. I almost couldn't stop cackling. I was so excited about that injury. Okay. And so I'm getting on a plane, and I'm like giddy. And my wife is like all mad at me. It's like, what is wrong with you? I was pretty sure the guy was going to live. And I kind of liked the fact that his tibia was sticking 6 inches out of his leg.
My dad's friend was driving last weekend and hit a tree. Doesn't even have a license because he had so many DUIs or whatever.
So what do you do when they won't give you a license? Just drive anyways. What are they going to do to me?
He broke his finger, but he hopped in the passenger seat. So when the cops got there, he told them the guy driving ran.
But there was. Did they believe him?
Yeah.
Dude, I wonder if he gave him a real name. They're gonna go haul one of his neighbors out in cuffs.
Oh, apparently it's finally ready.
Police are going to come.
Oh, nice.
He said it was
Only took a week and a half.
Are you looking at pictures of the injury?
Oh,
He decided to look him up.
Oh, you never saw that?
There's this one that someone stuck Rafiki and Simba off the side of the bone, so it's like it's Pride Rock.
Super specific.
Yeah, see, the soccer injuries are kind of the best. When the guy's like sliding, their foot gets caught up, and the whole lower part of their leg just shoves out by their ankle.
Watching Navarro Bowman's knee bend in the NFC Championship game 2 years ago.
Yeah, but nothing popped out.
when you see a knee make a
Yeah, I'm all about the unnatural bending of limbs. Okay, but that's kind of second tier to when bones leave the flesh. We have Dave Enters come down for a psychological evaluation. All right, let's talk about some stuff. All right, so no homework assignment because I kept you late last time. Is that the punchline?
Yeah.
That's terrible. All right. So what were we doing last time? Oh,
Fixing it.
fixing what?
You fixed it after class to handle the double parentheses.
Oh, yeah. So we were handling things like this, right? Okay. So, yeah, the thing we did right after class was we were originally looking for different tokens last time. So we were searching for a token. The token we might be looking for is that originally we wrote this guy, this get next token that took a string. And it took in a string of legal characters. And a weakness that we had in what we wrote last time was, what if you were looking for an opening parenthesis? Well, opening parenthesis is the set of legal characters. Well, you're actually going to burn past both of these with that one method, because it's going to keep walking until it's hit something it's not one of the legal characters. So, that's a legal character. That's also a legal character. It'll burn through it twice. So what we did is I wrote a second version of get next token that takes a char as a parameter. I think as Josh had suggested in the first place. So we took a second one that took a character as a parameter, and we just searched for that one character. Because the whole point of this is to burn past the one character. Because remember what we were talking about last time is this idea that we have our syntax tree, and there's large swaths of this that are kind of unimportant to us in terms of evaluating an expression. We're evaluating a statement, okay? So when we look at this guy here, the parentheses to us have meaning, correct? But we don't need to store that meaning as much as we need to make sure things fall into the correct levels of the syntax tree. So, for instance, we're calling this entire thing here, what did I call it? Apple. I must have changed the name there, Apple, for some reason. Well, we'll just do it.
I think you used Apple just to make it longer.
Yeah.
Oh, just to kind of prove we can read more than one character?
Yeah.
Kind of thing. All right, so we have this whole thing. Here's the var-def expression, or var-def statement. And we've decided for our little world, that's the only thing we support. This is a language of statements, only statements of var-def statement. So for our var-def statement, we're expecting a variable name followed by an equal sign, but the equal sign we're just going to burn past. That's not important for us to store in our syntax tree. We just know we're expecting it in terms of the syntax we receive as we're parsing it. So we burn past that, then we're expecting a math expression. Everything to the right-hand side of the equal sign should be a math expression. So we're going to start walking through this math expression. And as we're walking through the math expression, we're going to read things one character at a time, and we're going to get one of several things. As soon as we hit an opening parenthesis, we know we're dealing with a new math expression. Specifically, it's a parenthesis expression, right? Kind of what we were calling it last time. That then allows us to say, okay, we're now reading in a variable name, followed by an operator, followed by a variable name. Did we say we were going to support literals? Like, can we say 5 times 4?
No.
Okay, so just variable names. All right. Okay, so we know we're searching for a variable name, which is just going to be a collection of characters that don't match some of our other things, followed by an operator, which is going to be one of our normal operators, followed by a variable name, followed by a closing parenthesis. So we know when we have an opening parenthesis, we're going to bookend that with looking for the closing parenthesis token. Okay? So let's look at our code and see what it's currently doing along these lines. So here in driver, we're going to do this version of parser. And we'll change that to Apple just to match our example. Okay. So we call parser. Parser is going to come in here. Here's the constructor for it. We'll set the statement equal to whatever the statement was. It's our string. We'll set pause off at 0. Then we need to tell our parser to parse. All right. And when we tell our parser to parse, what does it do? Comes in here and it calls parse statement. Okay, because we have a language of statements here. Parse statements down here. So parse statement says, okay, when we're parsing a statement, our only kind of statement is a variable name, or is a variable statement. So the very first thing we're going to do is we're going to read our variable name. So we're going to say, get the next token. We're going to call the string version of our get next token, giving it the legal variable characters, which is up here. We made this a static variable, which means it only exists once. And here's all the stuff that make up our variables. And we have the space for the very end to read in that final, to burn past the final spaces, right? We decided that, and we can make an argument where we put those spaces, but we decided that we would assume that we're always getting legal syntax, which means somebody won't give us a variable name with a space in the middle of it. So we can assume that our code will never get that. Okay? Which is perfectly acceptable for what we're accomplishing in here. We're not writing a language anybody's going to use. We're just working with syntax trees. Okay? So don't spend time doing a lot of error checking. Go ahead.
Do languages even accept that?
They don't, but our language actually would. So what I'm saying is if we did give a space here, we would collect it. Our variable name would be AP space PLE. And be cool with that. that's our current world that we're in. In fact, actually, wouldn't it also get all this stuff? And then we decided we trim at the end, correct? To get the stuff off the ends, but we'd still have that space in the middle. So that's not a legal variable name in any language that I'm aware of. But in ours, it would be. that's legit enough. But whatever. You can assume legal syntax coming in. All right, so as long as it's a letter of the alphabet, upper or lowercase, or a space, we're going to accept that as being a variable. So we'll get our variable name right here. Then we print out, we read the variable. Then we're going to burn past the next token. And notice we're calling the new version of this guy, the one that takes just a char. Because we know all we're looking for is a single character. That is the equal sign, the assignment operator in our Java world. Okay, so we'll go and burn past that. And we can even, we could say we read that if we wanted to. In fact, let's do that. Let's just be fairly verbose here. So we're going to say burned. Burn the equal sign. Since we're already on a kind of a trend of violence here today. All right.
Burning things is in what that guy was smoking.
Well, no, we had the leg stuff. And
I was talking about what the boat guy was smoking.
That's true. I don't know if it was smoking or syringes. It was probably both.
Meth. I'd say meth.
Could be. Okay, so in any case, after we get that equal sign, we know whatever's on the right-hand side of the assignment operator, this whole thing would be something we call a math expression, right? And then at the very end, we're going to burn a semicolon. Okay, so before we even do the math expression part, we want to go all the way down here to the end, and we're saying burn past the semicolon. So we'll say burned semicolon there. All right, then we're parsing our math expression. So our math expression could be a very simple math expression, or it could be a more complex math expression like we're dealing with here. So this is when we call parse math expression. Now, just from a language perspective, understand the difference between expressions and statements largely has to do I mean, they do serve different functions, but in this particular case, we don't care about the functions so much. But typically statements end in semicolons, expressions do not. So that is an expression. Okay, we are expressing some math stuff because that's the only kind of expression that exists in our language here. So A times B minus C. So now we're going to start parsing this math expression. And the very first thing we're going to look for is a variable name. Okay, so we're going to try to read the variable name, and again, the legal characters for our variable names are letters of the alphabet, upper and lowercase, and a space, correct? Right after we tried to read the variable name, we're going to ask the question, is the variable name's length 0? Which means we didn't get a variable name. In our world right now, that means we got a opening parenthesis. That's the only thing we support in our language, right? If we didn't read a variable name, that means the very first thing we bumped into that wasn't a space, because remember we burned through spaces, because that's legal, was an opening parenthesis, which would have then failed, and then we would have returned the trimmed version of that variable name, which actually would be nothing, because we won't actually read in that character that was the illegal character. So we won't get the opening parenthesis. So if our code looked like this, we would be reading in variable name, variable, 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 variable. We'd hit this and say, oh, we're done. Here's my variable name. Trim it, which then becomes empty string, right? Because we're going to get all the spaces off the beginning and the end, which that's all there is. This thing's all spaces. So now the variable name that we actually had returned there would have had a length of 0. If its length was 0, we know we're dealing with a parenthesis math expression. Make sense? And what do we do with parenthesis math expressions? Well, we burn the parenthesis, parse the math expression, burn the parenthesis. So let's we'll write that, the burn. So we got the little kind of a little sandwich that we're making here. All right, and in the middle here, we're actually recursively calling the same method. But understand that pause is changing, right? Our get next token methods, they update the value of pause. So we have this global variable here called pause that's kind of walking down our string. Walking down our string. All right, so understand that when we parse math expression here, we might call that multiple times if there's parentheses inside of parentheses inside of parentheses, blah, blah, blah. So eventually, after we deal with all that, if the variable name was not empty, if we actually read in a variable name, then we're going to be inside this else. So we'll say we read variable name, whatever the variable will be. So the very first time through this, we're going to go through all this, return the trimmed version of this variable name, see that our variable name is 0, which means we'll get inside that first. The variable name's length is 0, which means we'll get inside that first if statement, which says burn the opening parenthesis, then parse the math expression, then burn the closing parenthesis. So after I burn the opening parenthesis, I should be sitting right here. Then I'm going to read in a variable. So I'll read in that. And then trim it, so it's just going to be, the variable is just going to be this guy. The length is not 0. So I'll say I read in variable A. Then I'm looking for an operator. So here's read in variable var name. Then let's get our operator. Then I say read in op. So operators are whatever our legal operators are. Then I'm going to read in the next variable name. So I'll read in first variable name, we'll say read in A. Read in the operator, read in times. Read in the next variable name, read in B. Then I'm going to read in my closing parenthesis. Where did that come from? That came from this right here. So when I read that opening parenthesis, I burned past it, then I called parse math expression, which read in this A, this guy, and was doing everything down here. That version of parse math expression. After that version of parse math expression was done, we returned to this line right here, the line following the original call to it. And we decided burn past the closing parenthesis. So we'll burn past this guy. What do we do after we burn past that guy? We go to the stuff following the else. So I'm only either going to do this stuff up here or I'm going to do this stuff up here. Either case, I'm going to read in an operator next. The operator I read in this case, was a minus. Then I'm going to read in my next variable name. I'll ask the same question. Was it a real variable name? If not, it must have been an opening parenthesis, so do the same crap we did before. Otherwise, say I read in the variable name. So this is going to recursively call parse math expression over and over and over again until we've gotten all the complexity on the right-hand side of our assignment operator. In the very, very end, all the way up here, after my original call to parse math expression finally returns, which might only be a single call if I have a very simple math expression, A times B, for example. But if I have anything with parentheses, parse math expression actually got called multiple times within that, recursively called. But in the end, I'll finally burn past the semicolon and we're done. So when I run this code now, I should see red apple, burned equal sign, red parenthesis, or no, then I should see burned opening parenthesis, red A, red times, red B, burned closing parenthesis, red minus, red C, burned semicolon. That's what I should see for this input. Red apple, burned equal sign, burned opening parenthesis, red A, red times, red B, burned closing parenthesis, red minus, red C, burned semicolon. Okay, proving that we're parsing through this statement correctly. Now at this point, all I've done is actually gone through and read individual tokens. I've done nothing with them. Make sense? So everything that we've done up to this point has nothing to do with syntax trees. It just has to do with parsing syntax. Now I got to put it somewhere. Okay, we're putting it into a syntax tree so we can do stuff to it later on. Okay, whether we evaluate it or whether we build it into something that's larger, we have a collection of statements. We're dealing with a syntax tree for a simple single statement. By simple, I mean it's just a variable definition statement where variable name, math expression. That's what we support. Okay, so now, given that, and this is kind of what we dealt with here, as we were walking through here, I started off with my variable def statement. So I want that to be in my syntax tree. Then I need to have I want him to have a child. The child's going to be well, I think before we called this a variable expression, just a variable name, something like that. Followed by a math expression. We need to create objects for storing these different things. Okay? The objects are what's going to be stored within our syntax tree. So what are the different players that we have here in our world of statements? Well, the entire thing here is a var def statement. Okay? And we're going to actually build a little bit of an inheritance model for this so that we could expand it if we wanted to. Okay? A var def statement, actually, for what we're doing here, is that going to benefit us or is that just going to confuse us? It'll confuse us. So we're going to go ahead and create an object for our var def statement. Let's define it here. Okay, what are the parts of a var def statement that we're interested in?
Operators and variables.
Well, do we care about the equal sign?
Not really.
So really a var def statement is a variable name and a math expression. That's it. 2 pieces. 2 things that we're interested in. Variable name, math expression. Well, let's write it here first. Var name and our math expression. Now, having said that, what's a math expression? What's a math expression? What's that? I'm going to build the math expression object as well. So when I look at a math expression, what is a math expression?
2 variables with operator.
Yeah, 2 variables and an operator. So left operand, right operand, operator. Okay, so 3 pieces of information. And right now, let's just store everything as strings. Okay, just to keep things simple. Java string language, we can convert it to whatever we need to later on. All right, so we have a left operand, we have a right operand, and we have an op. We'll just spell it out. We have an operator. Those are the 3 pieces of information that make up a math expression. Right? Okay. Oh, I'm so excited about this homework assignment. I mean, the Gideons wouldn't touch this chapter of the Bible. All right, so we're going to do what I call it, var def. Oh, can't have a minus, got to do under. So we're going to call this a var def. Well, this is a class name. So I'm going to name it capital V, var def statement. Good enough. Okay. All right, we decided that var def statements have 2 pieces of information. We have a private string var name, and we have a private what's going to be a math expression. Math expression. Well, we haven't defined math expressions yet. So save this for right now. Let's go define our math expressions. We're going to create a new class. This is going to be a math expression. I'll spell it out. Because I spelled out statement right. Math expression. All right, we decided math expressions. It's going to be a private string left operand, private string right operand, and a private char operator. While we're spelling things out. All right, so that's our math expression. Now we're going to need constructors for both these guys, but let's bounce back real quick to our statement so we can add that second parameter, that second variable to him, because now we have math expressions defined. Okay, so this guy is also going to have a var def expression, a var def statement is going to keep track of a math expression called the math expr. Good enough. Okay. So when we build a var def statement, what are we going to do? We're going to have a public constructor. It's going to be var def statement. It's going to take in a string var name, and it's going to take in a math expression, the math expression. And we'll set this dot var name equal to var name, and this dot the math expression equal to the math expression. Okay? And we'll go ahead and generate getters for these guys. Not setters, just getters. For now, we can always add setters later if we want. So I'll do let's source, generate getters and setters. And we'll expand both of these. And let's just give ourselves the ability to get at our math expression and our variable names. All right. Feels very funny putting semicolons in now. I've been programming in Swift a lot lately. There's no semicolons in that language. So when I bounce back and forth between Java and Swift, I start not putting semicolons here But then when I go to Swift, I keep putting semicolons there. But I spent all morning this morning doing Python and JavaScript for Node. At least those have semicolons. Okay, so this is our var_def statement. Math expression, we're going to have our constructor. Public math expression, this guy's going to take in a string left operand, a string right operand, and a char operator. And we'll say this dot left operand is equal to this dot left operand, then take the this off. So I don't have to spell as much. This dot right operand, I'll just copy this. It's equal to right operand, and this dot operator is equal to operator. Okay, and again, let's go ahead and give ourselves getters for this. Actually, you know what? I don't think we need. I don't think we need getters for this guy. We won't add getters for this guy. In fact, you know what? I don't think I need a getter for the math expression here either. I'll leave the other one in. That might be beneficial for your homework assignment. You can always add the other ones in if you need them, but I don't want to put more stuff in there than we need. I like to organically grow the code. I bet you the guy I bought a boat from wants to organically grow some stuff too. Keep my guess.
No, artificial. That's always artificial.
Really?
Yeah.
Well,
No.
That's
when
it.
you look at it, it's all.
The extent of my meth knowledge comes from Breaking Bad.
Pseudoephedrine is completely artificially.
Why do you know so much about this?
On Breaking Bad gives you a pretty good breakdown.
Yeah.
And it's not.
If you get bored at night and watch YouTube enough, you will learn everything.
I have to go 3 counties over before they let me into a Target.
Meth heads are making meth all the time. I mean, it can't be that difficult to make.
It's really
That's
not.
very true.
Some meth head put up a video on YouTube of him making meth, like as a tutorial. It was hilarious because on the same account later, the police put up a video of him getting arrested.
I mean, you know, at some point though, like the judge has to just. Isn't there like a reduction in sentence for being an idiot?
No.
Like I referenced it from the movie A Few Good Men. Tom Cruise is a lawyer in it. Have you guys seen the movie?
Yeah.
You know, and yeah, his the guy he was representing at the beginning of the movie was the guy who was selling oregano as if it was marijuana. Okay? And the guy didn't know it was oregano. Okay? So he really thought he was selling marijuana. But technically he didn't break any laws. He sold somebody, like, what is my client guilty of? He sold a condiment. My client's an idiot. You know, so I mean, really, actually, is it illegal to make meth if you don't use it or sell it?
Yes.
It is?
Yep. Because then you're in possession of controlled substance.
Oh, that makes sense. What if you never possess it? You made it, but you just completely back away.
That's what a lot of
But
people
I
do.
have never touched it.
So
You should know the answer to this.
Well, that's what a lot of people do. They make it inside a 2-liter bottle and they'll throw it in a ditch.
I have to make sure that we completely offend everybody in this thing. That way I have my lawyer has when he's representing me based on today's content, we're good to go. That's right. That's right. Okay, so we have our var_def statement, which is a collection of a variable name and its associated math expression. But our math expression may actually be somewhat complex, right? Okay, so now we got to go back over to the math expression side of things. When we deal with the math expression, it's going to have a left operand and it's going to have a right operand. But these operands may be what? We look at our example of our math expression here. We have, so our variable expression is variable name followed by math expression, how would we objectively, in an object-oriented fashion, represent that slightly more complex math expression? Isn't this our left operand? And this is our right operand?
Yeah.
Isn't this a left operand?
Yes.
And this is a right operand? What kind of left operand is this?
Math expression.
It's a math expression. What type of left operand is that? Do math expressions come in two flavors? Okay. Do we have a math expression that's a left operand followed by an operator followed by a right operand? And then do we have another version of a math expression that's just a variable name?
Mhm.
Does that make sense?
What would it be? It wouldn't really be a math expression on the right, would it? Because it is just.
That's just a left operator.
You can assign the result of the math expression to the variable.
Well, we're going to have to build objects for these. And if right now my left side in this example is a math expression, not just a string, what do I do with that? I need to break it down to a math expression. Well, now my left side, we can see it as being a string. But don't we, if we're going to store, if a math expression stores a math expression followed by an operator followed by a math expression, don't we need to have the ability of taking a math expression and saying, are you a real math expression or are you a variable math expression? Does that make sense? We need to kind of have two separate types of math expressions. How do we pull that off? Would you call this guy a math expression or would you just call that an expression? Really, I mean, just an expression, correct? We can maybe call it a var expression. You can have a var expression. All right, so what we might do here is programmatically, we're going to say a math expression is a left operand followed by a right operand followed by an operator. Okay, but really this left operand is a math expression. So let's change the name of this to match our code. The right operand is going to be a math expression. And the operator is going to be a char. Okay? But the left operand could be a math expression, or it could also be just a variable name, which is just an expression. Make sense? But we're going to have a top level guy, so we can store both of these. So we're actually going to create this model. We have expression. We're going to have a var expression. And we're going to have a math expression. Both of these are going to be expressions. Okay, they're both going to come from the abstract class expression. Now, expression in and of itself is not going to do anything, at least not yet. In a more complex language, you might have some generic stuff an expression can do. But really what we're using it here for is to support the object-oriented model. So we're going to have an abstract class called expression. What does it mean for a class to be abstract? Pebbles. What does it mean for a class to be abstract?
I'm trying to figure out myself.
All right. Let's see. Next in my pecking order. I wonder what version of Levi we have today. Levi's always a dice roll. He's either like one of the brightest guys in class, or he's been asleep for 2 weeks. It's like, what class is this? All right, what's an abstract class? What does that mean?
It can be instantiated, it's just, it doesn't have a constructor, right?
It can actually have a constructor, but we can't directly instantiate it. It could have a constructor. It's built to support the inheritance model. It's built to support things like this. We potentially could have fields. It could have a constructor that its children call upon. But you can never actually call its constructor directly because you can't create an instance of classes that are abstract. Okay? So we're going to go ahead and create an abstract class called expression. We'll do this programmatically here. All right, and we'll even use Eclipse a little bit. There's a little checkbox here to make this guy abstract. So we'll do that. We'll make him abstract. All right, and I'm gonna leave this class alone from here. I'm not gonna actually do anything else with it. All he is there to support the inheritance model, because what I want to be able to do ultimately is inside my math expression, wherever that guy is, I want to be able to say the left operand is an expression and the right operand is an expression. And these expressions could either be math expressions or var expressions. We have two flavors of expressions. So that means I needed this expression object that we never have a generic expression. It can't exist. We made sure of that by making it abstract. But we have things that are expressions, var expressions and math expressions, that both are expressions. Okay? So a math expression, we decided, is a left operand, which is an expression, and a right operand, which is an expression. These guys might be math expressions, they might be var expressions. We don't know, we just know that they at the very least are expressions. And we can ask what kind they are later. And then they have an operator in between. Okay? Now we have our var expression. And a var expression is just going to have a variable name. Right? Of type string. That's all that guy is. Pretty simple object. So let's go ahead and create our class for var expression. All right, so we're going to say var expression extends expression. So that guy is an expression. Similarly, math expression extends expression. So both of these categorically are expressions. A math expression is both an expression and a math expression. A var expression is both an expression and a var expression, but a var expression is not a math expression. A math expression is not a var expression. Okay, they both have the same parent class, but they're not equivalent to each other. They just both happen to be expressions. Okay? So math expression will have a private left operand that is an expression. It will have a private right operand that is an expression. And then a char operator, which means that we need to take in an expression as the left operand and an expression as the right operand. Okay. Var expression is going to have a private string var name. Constructor for this guy, public var expression. We'll take in a string var name. And we'll say this dot var name is equal to var name. Okay, now, let's look at this guy again. We're going to go build our visual syntax tree again using our classes now. This is a var expression. Okay, this entire thing is a var def statement, right? A var def statement keeps track of two things. We originally said a string variable name, but actually, isn't that a var expression?
Mhm.
So this is a var expression for our var def statement. And let's fix the name of this, var def statement. So it's going to take a var expression, var name, and then a expression, expr, something like that. Although we guaranteed it would be a math expression on the right-hand side, didn't we? That's our rules that we made for our little language. Okay, so we could say math expression. Fair enough. So let's go update our var def statement code. So this guy no longer has a string name var name. Now it has a var expression. And let's call this guy the var expr. So instead of this guy taking in a string var name, he's going to take in a var expression, the var expr, and a math expression. Okay, you see how we've kind of built up our objects now? So, building our syntax tree out of this.
Are you gonna have to make a new getter for that?
Oh, thank you. Get, well, let's just. And actually, right now we might not even need getters. Just leave it. Just leave it for now. We can always add those if we need them. As far as we know right now, we don't need one. All right, so var def statement. So now we have the top level. Oh, here we go. We have a var def statement. A var def statement is a var expression followed by a math expression. Those are the components of a var def statement, correct? This particular var expression holds the single variable apple. Okay, so we can actually represent that just as some text. But we don't need to actually hang it off the tree here. We know that this var expression holds apple as the variable name. That's its field. So that would be var expression dot get var name, or get the var name, or whatever we called it. Okay. Math expression. The left-hand side is actually another math expression. The right-hand side is actually a var expression. Correct? So the syntax tree for this guy would look like this, var expression, and that variable is actually the variable C. This math expression here has a left operand, which is actually a, I'll steal both of these. Left operand is a var expression, A. Right operand is a var expression, B. And then in the middle, we actually just have a char. Times. Similarly, in the middle up here, let me scooch this a little bit. We have a minus. Does kind of make sense? So now we've used our objects to build out our syntax tree. The root node of our syntax tree is going to be a var def statement. The left node of that guy, because remember this is an n-ary tree, so this guy can have as many children as we want. But it just so happens that the syntax tree, that is a var def statement. Every var def statement is the root node of its own syntax tree. That make sense? So realistically speaking, when we're thinking about a left and a right node, isn't this our left tree? Isn't this our right tree? Notice how the concept of left node, left child, right child is actually encapsulated now inside of our objects. If I'm a var def statement, I know if I'm looking at this example here, if I'm this guy, I have two children, two branches that hang off. One of them is a var expression. The other one's a math expression. The structure has meaning. Similar to binary trees where the structure had meaning in terms of ordering. With a syntax tree, the structures have meaning in terms of what kind of animal they are, because later on we're going to come back and probably want to evaluate them. Make sense? So if I build a var def statement, I need to build him by creating a var expression and a math expression. This math expression in this case actually is more complex. Would you say that this guy is the root node of his own little syntax tree? But it's a little bit different. It's a syntax tree that follows a little bit different rules. A math expression has a left child that's an expression, a right child that's an expression, and a middle child, if you want. It doesn't matter where you put them, but you gotta organize them in some way. In fact, we really should call this an op expression. We can't really have these stragglers out here because we need to know what kind of thing we're dealing with to perform our operations. So with that in mind, I'm going to come in here and we're going to create another type of expression call this guy an op expression. And an op expression will extend expression. We need him to extend expression, but we're going to make him specifically an op expression. He can't be a generic expression. When we want an operator, it has to be an op expression. Okay? And this guy's just going to take in a char, the op. And we'll make this private. All right. And then we're going to have our constructor, public op expression. We'll take in a char, the op. We'll set this dot, the op equal to the op. All right, so that's our op expression. So to build out our tree a little bit more here, steal this, well, scoop that. This is an op expression. And this particular op is a minus, right? This math expression holds a var expression followed by an op expression. This particular guy is a times followed by a var expression. Good enough there. Just drag these guys over so they're clearly disconnected. We can drag this guy up. All right, kind of makes sense? So notice that every root node now is its own object. This is a syntax tree. A var_def statement syntax tree looks like var expression followed by a math expression. A var expression is not a syntax tree. It's a leaf node. It has a value apple. Math expression is a syntax tree. Its left tree will be an expression. Its right tree will be an expression. And its middle tree, doesn't matter which of these trees we actually set it as because we've labeled each of them. We can ask, what kind of expression are you? What kind of expression are you? What kind of expression are you? It doesn't matter what order they're in. Later on, we will need to say what kind, if we want to handle order of operation, we do have to handle, are you the left operator or the right operator? We do have to deal with that. But we are already organizing it that way. So, but not important for us right now. So don't even think that far ahead. This math expression is the root of its own syntax tree, where its left tree is an expression, its middle tree is an operator, well, operator expression, its right tree is a expression. See how this all breaks down? So this is a tree, which contains a tree, which contains a tree. Yep, that's it. Those are all the trees here. So if we want to color code them, the things that are actually syntax trees here are this guy. It's weird. Why did it mess up my? It's just rude. This guy. This guy. Yep, that's it. So in terms of things that actually function as trees here, notice everything that doesn't have a terminal. These would be called leaf nodes, leaf values. So leaf nodes are not trees, but everything else is a tree. Make sense? For your homework, build a syntax tree out of our expression. I've given you all the objects you need. All you have to do is don't think about it like I'm building some kind of crazy syntax tree. All you're doing is building a collection of objects that happen to represent a syntax tree. So by doing it this way, we've actually abstracted the syntax tree out. This thing will represent a syntax tree, but we've actually stored it as a collection of objects.
So what's our goal, like to print out?
Your goal will have to, I mean, if you want, you can have each of these objects capable of printing itself. But really what you'd have is you're going to have a var_def statement. That's your one, that's what's going to shoot out of there, is a var_def statement. Here is your parsed tree. And inside this guy is some stuff. And the stuff that's inside there is this. So if you want to print some stuff out to test it, that's fine. But that's not a requirement. Build the object model of it. I've almost given you everything you need to do it. You have all the objects. You have all the parsing. Now you just got to connect those two together. Build objects as you're parsing. Make sense? All right. So this should take no more than 15 or 20 hours. Some of you will finish this in 5 minutes. This could be done in 5 minutes. All right, so I'll go ahead and push this.
7 hours later, I'll be working on it. So yeah.